All right, combine your like terms. 16 plus 7 is 23. You still got the 2b. All right, 23 here. All right, subtract the 23. And you get 0 equals 2b. Divide by 2. And we get b equals 0. So again, in this case, b equals 0. All right. You're not always going to get b equal to 0. All right. In fact, in numbers 3 and 4, you will get b equals 0. So think about why you would get b equals 0 there. Okay. When you look at numbers 3 and 4, all right, you can see that the y-intercept is 0, 2, and it's symmetrical about the y-axis. So whenever you have a function, a quadratic function, where it's symmetrical about the y-axis, meaning that you could take this side and flip it over on this side and it would line up perfectly, right? If it's up there, or if it were to be down here, anywhere, right? If it's symmetrical about the y-axis, then the b value is going to be 0. So you can see right here that it's got a 4 on each side of the 2, which is our y-intercept. This one's got a 5 on each side of the 8, which is our y-intercept. If you go down to number 5, our y-intercept is 12, and it's 17, 11. It's not symmetrical about the y-intercept. Number 6, not symmetrical. So if you ever do see one that's symmetrical about the y-intercept, the b value is going to be 0. All right, and if you're not sure to check that, you just plug that into your calculator. All right, if you've got your a value for number 3 and you've got your c value for number 3, you can plug that in with the 0 for the b, or just don't plug in the x value in the middle there, and then you will have your function, and then you can see that it matches up. All right, so that is finding b. So you can skip over numbers 3 and 4 because they're symmetrical about the y-intercept, but numbers 5 and 6 should have different b values. They won't be 0. All right, so go ahead and find the b's on the rest of these. Thanks.